So we're continuing on in chapter 3 today. More things about fractions, and this is called rational numbers. The real definition of rational numbers, and we're going to write that up here at the top. A rational number is, if I can get it to write, any number that can be made into a fraction. Any number that can be made into a fraction. So pretty much every number that you guys have dealt with the exception of maybe 1, has been a rational number. Anybody know the one that I'm talking about that's not rational? Stephen? Pi. Pi is definitely not rational. You can't make it a fraction. And here's kind of how you tell. If it's a decimal number that does not repeat and it never ends, it never stops, that is what's called irrational. So pi is probably the most famous irrational number. And we'll talk more about irrational numbers later in the year when we start talking about square roots, because a lot of those are irrational. So all of these today pretty much will be rational, and they can be written as a fraction. So kind of just to check, what you will be asked to do is to take these numbers and to write them as a fraction. So some of them are pretty cut and dry and pretty easy. Some of them take a little bit more work. The first type of number that we're going to look at are whole numbers. And for whole numbers, to make it a fraction, you just put 1 under it. So for the 5, you would just put 5 over 1. So if you get a whole number, you put a 1 under it. Now, -3 is not a whole number. It would be called an integer, but it's along the same lines. You take -3 and put a 1 under it. So if it is a number without any decimals or fractions with it already, you just put it over 1 and you've made it a fraction. Mixed numbers, you need to make them improper, and it's that little trick where you multiply the denominator times the whole part and add the numerator. So 3 and 2/5, well, first of all, the denominator is going to be 5. That never changes. And 3 and 2/5 would be what, Sienna? 17 over 5, because 5 times 3 is 15 plus 2, 17 over 5. The -4 and 3/8, what do you think that's going to be? -4 and 3/8. Trayton? -35 over 8. Yeah, -35 over 8. I'm not quite sure why that box is blue, but I can't write in it with blue, so there we go. Yeah, if the number that you're given is negative, then you're definitely going to keep it negative. That won't change. Denominator of 8 will stay the same. 8 times 4 is 32, plus 3 is 35. So there you go. Next, we're going to switch to decimals. And you put the number above the decimal place value. So when I read 0.4, who can tell me how you should really read that number without saying the word point in front of it? Tori?
4 over 10 or 2 over 5.
Okay, but you would read it how? Without saying the word over. What is that number?
4 out of 10.
Instead of saying out of, it's 4 tenths. So when you see a decimal, however you read it formally, that's how you write it. So 0.4 is 4 tenths, and she was correct in saying you should go ahead and reduce that to 2/5. Okay, what about the 0.32? How do you read that without saying the word point? What place value is that? Stephen?
32 hundredths.
32 hundredths. So that's where you would begin. And Stephen, does that reduce, do you think?
I'm sure.
Are they both even?
Yes.
So if they're both even, you know you can divide out at least what?
Half.
Yeah, you can at least divide out 2. So what's 32 divided by 2?
16.
16. And what's 100 divided by 2?
50.
Okay, so look at 16 over 50. You think you can reduce that any further?
Yes.
Yeah, because they're both even again. So divide them both by 2. What would we get?
8/25.
Exactly right, 8/25. Now, we could have gone from the 32 over 100 straight there if you recognize that 4 went into both of those, or there's nothing wrong at all with what we just did, dividing out 2 until you couldn't divide anything out anymore. So 8/25. Okay, so anyway, that's how you change any of those numbers to a fraction. Any questions about those? All right, I am going to go down here. We're going to talk a little bit about repeating decimals and how those become a fraction. So the first one is 0.7 repeating. Now, when I read this little note up here, it says put over 9 depends on number of repeats. That probably means nothing to you right now. So hopefully this will help you remember. However many digits are repeating, so in 0.7 repeating it's 1. You take the number that's there, 7, and put it over 1, 9. That's 7/9. There is a process that I could prove this to you, but I think it would confuse you more than it would prove it, so we're not going to do it. If you were in algebra, we would show you, but it would be combining equations and things like that prove this, but I don't think it's worth it. So when it's repeating, 0.7 repeating, it's not 7/10 anymore. It's 7/9. So 0.25 repeating, there's 2 digits repeating, so we're going to put it over 99, and you would put 25 over 99. If anything would reduce out of that, you should do that, but in that case it doesn't. So the last one, Haley, what do you think?
175 over 999.
175 over 999. Yep. So, and you should check to see if anything reduces out of that, but I don't think it does. 175 over 999. I do need to show you this. If it would be like 6 point, I'm going to do one like this. 6.3 with the repeating bar over the 3. You would say 6 and 3/9. And since 3/9 reduces, you would actually say 6 and 1/3. So if there's a whole part with the decimal, it stays a whole part with a mixed number. If they said write that as a fraction and not as a mixed number, then you would have to do 6 times 3 plus 1, and then that would be 19/3. Question?
175 over 999 can reduce that.
What can you divide out of there?
3.
I don't think you can. Because 175, if you add 1 plus 7 plus 5, that's 13, and 3 doesn't go into 13. That's the trick for seeing if 3 goes into a number. You're thinking maybe of 75. 3 goes into 75,
Yeah, it does.
but it doesn't go into 175. 1 plus 7's 8 plus 5's 13. So 3 doesn't go into 13, so 3 wouldn't go into 175. If you add up all the digits and it's a multiple of 3, then 3 goes into it. Otherwise, it doesn't. Okay, we're going to talk about different sets of numbers right now and tell you what the sets look like, because you're going to have to decide if a number is whole, integer, rational, or maybe irrational. So let's check this out. For it to be a whole number is the set that starts with 0 and it goes with positive numbers with no decimals or fractions. So 0, 1, 2, 3, 4, 5, and so on. Those are just whole numbers. Now, some of the whole numbers fit into the category of integers. So if you have a number that's a whole number, it's also an integer. And here's how integers go. First of all, integers start from negative infinity. We've talked about that a little bit. They come from negative infinity, negative 3, negative 2, negative 1, 0, 1, 2, 3, and then it goes off to positive infinity. So any number positive or negative that doesn't have any decimals or fractions, that's considered integers. So just because it's an integer doesn't mean that it has to be a whole number. But if it's a whole number, it is automatically an integer. Does that make sense? All of the whole numbers fit inside the integer set. Now, rational, remember, anything that can be written as a fraction. So every number that we've looked at today is rational. So if it fits into one of those other two categories, it's definitely irrational. But there's some that are rational that aren't whole numbers and integers. So any kind of decimals or fractions, except ones that don't stop and don't repeat. Okay, so anything that stops or repeats, you can make it a fraction, so therefore it's rational. Okay, so we need to identify all sets. Hang on just a second. So what's going to happen in your homework, you're going to use just letters, and they're going to say W stands for whole, I stands for integer, and R stands for rational. All right, we're going to change that in your homework. That is actually Q for rational. I know that probably is strange, but R stands for another set of numbers called real, and we can't use it for this. So, okay, let's identify all sets. So if you're given the number -8, what set or sets do you think -8 belongs to? Is there anybody that hasn't gotten a ticket yet today that wants to try that? Okay, so I guess let's go with, all right, Trayton, what do you think for -8? Integer. Anything else? It's not a whole number, but if it's an integer, it's automatically what? A rational. So you would have to put I and Q on -8. What about 14? Haley, what do you think?
A whole number and a rational?
It's a whole number and it's a rational. If it's a whole number, is it an integer? Look at the list.
Yes.
Yes, so it would be all three. A W, I, and Q. You'd have to put all three. Okay, what about 1 and 5/9? 1 and 5/9. Any ideas on that one? Tori?
Rational?
Just rational. Okay, and last but not least, 3.141516 ... What are you thinking? Shane? Think it's rational? So does it stop? Does it repeat the same digits over and over?
No.
No. So can it be rational? No, this was a big trick question. So if it's not rational, it would have to be, huh? Not integer. Not a whole number. It's why it's a trick question. It's a trick question. It's not any of those. It's none. It's none. And then the word that it's not going to even be there is irrational, but you don't have a letter for it because we're not supposed to have actually mentioned it yet, but what, you can just say none. But what it really is it's an irrational number.